Hello and welcome to the first lesson of the electromagnetics booklet, lesson 1, conduction and convection. The key words for this lesson are conduction, convection, vibration, density and volume. The key question for this lesson is, how is heat transferred in solids and liquids? Pause the video, have a go at the first knowledge check, and we'll come back and check the answers. The answers to the first knowledge check. Question 1, list two phrases that describe particles in a solid. So you could say any two from atoms are arranged in rows or columns, atoms in fixed positions, atoms vibrate, and they have the fixed shape. Question number 2, list two phrases that describe particles in a liquid. We can pick any two from atoms are free to flow, atoms have random arrangements, all touching, takes the shape of the container. Question number 3, list two phrases that describe particles in a gas. Any two from atoms are free to move, atoms have random arrangement, many gaps between them, and they take the shape of the container. Question 4, what state of particles vibrate but cannot change position? So that state is a solid. Which state has the strongest bonds between particles? That's also a solid. Question number 6, what state has particles that vibrate and can change position? That's a liquid. You could also say it's a gas as well, but mainly liquid. Identify the unit of thermal energy, the joule. Remember, all energy is in joules. Internal energy is the sum of what two energies? Potential and kinetic energy. Give yourself a score, write it on the side. Overview of the lesson. By the end of the lesson, you should be able to describe the heat transfer in solids, describe heat transfer in fluids. Heat and temperature. Heat is a measure. So heat is a measure of the amount of energy in the thermal store. The unit of energy, so unit of energy is always the joule. Temperature is a measure of the average energy in the kinetic store of the particle. So temperature is a measure of the energy, average energy in the kinetic store of the particles in the material. Temperature is measured in degrees Celsius in the UK or degrees Kelvin. Heat will always flow from hot to cold. So remember, thermal store is the kinetic and potential energies of the particles. The kinetic energy is in the movement of the particles, and the potential energy is mainly in the bonds. So it's really important to note temperature is not the same as heat. Think of heat as the total energy and temperature as the hotness. Clarify that point on heat and temperature as well. So heat is the movement, the sum of the movement or the kinetic energies of all these particles. So it's the sum of all the kinetic energies. So sum of all the kinetic energy plus the potential energy, the energy which is stored in the bonds between the particles. Whereas temperature is the average movement. So if we take these four particles and they're moving, so you add up, you sum up the kinetic energy. So you sum up the kinetic energy of these particles, and then you divide it between them. So you divide by the number of particles, so it becomes an average. So this is a average, and this is a sum. So this is the total energy, and this is just an average. To look at it is, if we compare two beakers, we have a small beaker has a higher temperature, and we have a large beaker at a lower temperature. So one's at 90 degrees, one's at 50 degrees. Here the temperature is higher, so the temperature is higher. Here the temperature is lower, but this contains less heat or thermal energy in its thermal store, so less thermal energy because there's less particles. The particles might be vibrating around more quickly, so the individual particles are moving more quickly, and when we average it out, the temperature will be greater. So the temperature is greater. Here the thermal energy is greater, so here it's less because there's less particles. Here we have more particles, so when we add the energy of all the individual particles, the thermal energy or the heat in the system will be greater. Now we're going to just revisit the particle model, and we know that in solids particles are arranged in rows close together, and they still vibrate, but they vibrate about fixed positions. There's no net movement of matter. So this individual particle here is moving, it's vibrating, but it doesn't move across the material. So there's no net movement of matter. Energy store in solids. When particles increase their thermal store, they vibrate more. Because the particles are close together, when one vibrates, it causes the next one to vibrate. So think of it as a domino effect. So once one starts to vibrate, it passes on the energy to the next particle, and so on. And this process is called conduction. So remember, as particles increase their thermal store and they vibrate more, the kinetic energy increases, and so does the temperature, because the temperature is dependent on the kinetic energy. Now, bonds between particles in different materials can be weaker or stronger. Therefore, heat can conduct at different rates depending on how hard it is for the particles to vibrate. So the way to think of this is you can have a particle, the bonds are shown here with a spring. Some of the springs will be stiffer. So if it's stiffer, it requires more energy to cause them to vibrate. So not all bonds in materials are the same. So think of them as springs, and if they're stiffer, they require more energy. Also, you have to note that the masses of the particles can be different as well. So materials are different. So if it has a greater mass, it requires more energy to cause it to move. Observe a demonstration of of a piece of equipment called a conduction cross, which has different sheets of metal attached to a wooden frame. Once you've watched the practical, we're going to come back and we're going to fill in some values. Hopefully you'll get to do this in the lab as well.
This is a really quick demo to show you conduction. So I have a conduction cross here as 4 different metals: copper, aluminium, iron and brass, and onto the ends of each of these I've put some drawing pins which I've attached with Vaseline. So if I turn that upside down, they won't fall off. I'm just going to pop this on top of my tripod here, making sure that each of the drawing pins are actually free away from the tripod and aren't being secured on. So what I'm going to do is heat the middle of the cross and we're going to see which one falls off. So brass is down the bottom, iron is on this side, copper is on this side, and aluminium's at the top. They should all fall off once the Vaseline melts. Okay, so iron's fallen off, aluminium's fallen off already. Copper has fallen off and I can confirm it's quite hot. Brass has just fallen off. And iron's just fallen off.
What I've noticed is that the copper was the best conductor because the tack fell off the end of the piece of metal the quickest. So I'm just going to put some arbitrary values in. So we'll say that's 15 seconds. Brass again was the next quickest, followed by the steel. Note that brass is a copper alloy and steel is a iron alloy. So even though it did say in this practical that we're going to look at steel, in the video that you watch it was actually iron, but they're roughly similar in this case. Now again, this practical demonstrated different materials and how there's difference in the conduction of those materials as well. Now we're going to look at a movement of thermal energy within fluids. So we're going to look at convection. So fluids are known as substances that have no particular shape, and they include both liquids and gases. The particle model tells us that fluids, particles are free to move. We found that if a fluid is heated, so if you heat a fluid, it expands. Just going to make a note here. The fluid expands, not the particles. So the particles do not expand. Particles do not expand. The fluid expands. The space increases between the particles. So it has a greater volume. Since density is equal to mass over volume, this means that the fluid density decreases. If an object becomes less dense than its surroundings, it floats, or another word for floats is it rises. Now the warm fluid becomes less dense, so floats upwards. So once again, I'm just going to show you if we have a beaker, at the bottom you have a heat source. So you have a heat source at the bottom, as you heat the water, these particles begin to vibrate more. The distance between the particles increases, so they become less dense and they rise upwards. And once they reach the top, they cool down and they fall down. So as we heat it, density decreases as it moves. As we heat it, it rises up, and as it cools down, it falls back down. Now, here we have the equation for density, mass over volume, so we'll have a look at that. Remember the line here, mass divided by, so this line is divide by. As we increase the denominator, so as we increase the volume, the density goes down. So as we increase the volume in this equation, the density shown by rho decreases. One of the practicals you'll do in the lab is put some potassium permanganate dye into some water and set up some convection currents by heating up the water. So this is to look at convection currents in fluids. Because we're not in the lab at the moment, watch the following video which will show you the demonstration. Then come back and just fill in the table here. So describe the movement of the die. So what we saw in the video was we started off with some water, and at the bottom we had some potassium permanganate crystals, so I'll just call that die. And the die, what we notice, settles to the bottom of the beaker, and there's very little movement. Once we start heating it, what we start noticing is the die starts to rise upwards and it forms swirling patterns. So the die is rising. So die rises as it is heated and falls as it cools nearer to the top. Setting currents. So we set up these currents that swirl around, and this is because the change in density. So at the bottom it has a lower density because it's being heated. It rises as it cools, the density increases because it contracts again, and then it falls down. Really important to know that conduction also happens in liquids and gases. We mentioned mainly conduction happens in solids because that's a main mechanism, but it also happens in liquids and gases. And what you're going to do now is watch a series of videos based on the practicals that you should be doing in the lab, and then we're going to come back and we're going to fill in these parts based on what we've observed. First practical that you saw was some ice at the bottom of a test tube held by some wire wool or gauze material. Here we have some water, and we applied heat to the top, not the bottom but the top. And what we saw, what happened to the ice? The ice does not melt. And explain your observations. And the reason it doesn't melt is because that water is a relatively poor conductor of thermal energy or heat. So it's not conducting downwards. Instead, what's happening is, so little of the heat energy reaches the ice. The main mechanism is convection. So the convection actually carries the heat upwards and outwards rather than downwards. So most heat is transferred to the air via convection. And remember, convection currents rise. The particle that you observed was a match next to a naked flame. The match, you notice, didn't ignite, and the reason it didn't ignite is that air is a poor conductor of heat. Now the next practical you observed was a water balloon held over a naked flame. So why does the balloon not pop? And the reason is the water is a better conductor of heat energy than the rubber material of the balloon. So it conducts the heat away. So the rubber does not burst. So the next practical that we're going to observe on video is convection current set up in gases. So in this case air, and we're going to use a convection snake to demonstrate this. So once you watch your video, come back and we'll fill in this section here.
Wow.
What happens to the spiral? The spiral snake begins to rotate as convection currents transfer energy to the snake causing it to rotate. So what you're doing is you're heating up the air over here. It's the air itself is expanding, it's becoming less dense, and it rises. It's then transferring that thermal energy to the kinetic energy of the air particles. So it's now in the kinetic store of the air particles. They then transfer it to the snake, the kinetic store of the snake, and the snake starts to then rotate. It does work. Again, this is also summarized in this video, so when you get a chance, watch the video. Go at the last knowledge check, then come back and we'll check the answers together. Number one, conduction happens in solid, liquid and gases. It happens in all three. It just happens to be solids are better at conducting. Convection happens in solid, liquid or gases. Convection happens in liquids and gases. Describe the direction of heat flow. Is from hot to cold. State how heat is transferred by conduction through vibration of particles. Describe the change in volume when a fluid is heated. The volume increases. Why do heated fluids rise? They become less dense, so rise. Question number 7. State which is better, heat conductor, copper or steel? Copper. Which causes the wind, conduction or convection? It's convection. Check your answers and write your score on the side.